examples today and then try to give you guys some time to work on your homework so you can get that caught up. So I just want to write this as an integral. Okay, we know an integral is this. If I have an integral, what do we have to have on the end? Dx. Okay, so we're looking for something like this. dy dx, what does that represent? The derivative. So this means the derivative is secant of x. Do we know anything that has a derivative of secant? No. So I'm asking you to write it as an integral, which means we would have to be able to think backwards. However, we learned Friday that if you have both an integral and a derivative, what do they really do? They cancel each other out, right? Okay, we know also that y of 2 is equal to 3. So this is like a point saying if x is 2, the y is 3. So we're not doing anything too crazy here. What we were working on last week, we figured out if you go from a number up to a variable, so a lot of times we did x's, then if you were doing the derivative of an integral, all you had to do is replace this variable with the x, right? So if I wanted to write this, since I can't actually do the antiderivative of secant, we could think of it like this, but if I change that variable to a t, this needs to be a dt. Okay, so if I go from a number up to x, when I did the derivative of this, we would just get secant of x. You guys all agree with that? So this requirement is met. We are trying to write an overall function. This is like my y of x. When I plug in a 2, it has to be equal to 3. I could start this at any constant I wanted. If I started at 2, if you integrate from 2 to 2, what do you get? 0. So what would I have to do in order to have the 3? What would I need on a plus 3 on the end? And that's the benefit of choosing to start at 2 versus if I started at 0, then I would have to have the secant of something plus a number equals 3 and it would be much uglier. So we are writing a possible integral, but not the only one. All right, I didn't ask you to solve anything. This is our answer. This is our integral. And it just uses that fundamental theorem there. Let's go ahead and do this one. The numbers at the end are pretty ugly, but it's good practice for us. If we want to do this antiderivative, what do we need to do first? Simplify. Okay, a cube root, that's like a 1/3, and if you're dividing, what do you do with your exponents? So 2 minus 1/3, so 2 is like 6 over 3, minus 1 over 3 is 5 over 3. This is a 1, so 3 over 3 minus 1 over 3 is 2 over 3. And then this would be 3x to what power? Right, antiderivative. So if you add 1 to the power, 5/3 plus 1, so 5 over 3 plus 3 over 3 is 8 over 3. There's 3/8 in front. Okay, 2/3 plus 1, so 2 over 3 plus 3 over 3 is 5 over 3. Over the 3/5. Okay, negative 1/3 plus 1, so negative 1 over 3 plus 3 over 3 is 2 over 3. So you'd have a 3 over 2 in front times the 3 that's already there would be a 9 over 2. This is going to get ugly, I think. So if I put in my negative 1, okay, cube root of negative 1 is negative 1, 2 to the 8th is a positive, so we just get 3/8. Cube root of negative 1 is negative 1 to a negative, or to the 5th is still negative, times negative 3/5 is positive. Cube root of negative 1 is negative 1 squared is positive. Minus. All right, we can keep this in radicals. Let's just go ahead and do decimals. So if I put in my -2, and I'm just going to type this all in because it's not nice. So 3/8 times -2 to the 8/3 minus 3/5 times -2 to the 5/3. 9/2 times -2 to the 2/3. And so then if I plug this all in, -5.9543. Throwing in a lot of review of intervals that we did before, just because they're not going away. Is that one okay? Find the total area bounded by f of x equals x cubed minus 9x and the x-axis. So let's think about a picture here. If I want to know, let's find out where that hits the x-axis. Let's see when that equals 0. X squared minus 9 factors into x plus 3, x minus 3. So my x-intercepts are 0, 3, and -3. Okay. If we think about this graph, we know x cubed. Do you guys remember your end behavior? It's like the chair, so the left end is pointing down. It's the x-axis, the right end has to be pointing up. So our graph looks something like this. I'm asking you to find the area between it and the x-axis. When I say total area, what I'm referring to here is like the absolute value of the area. So I don't want you to think of this as a positive and this as a negative like normal. I'm wanting you to find this chunk and add it to this chunk, okay? So we know if we just integrated from -3 to +3, it would subtract off this portion that was below. But because I'm asking for the total area contained, not just the integral, we have to think of those as the absolute value. So we'll have to go from -3 to 0. That section is above the x-axis, so we don't have to worry, it would be a positive anyway. But when we go from 0 to 3, that section was below, so it will turn out to be negative. How do we make it a positive? Yeah, we run a negative through. It's like doing the absolute value. Right. Antiderivative of x cubed, 4th x to the 4th, minus antiderivative of 9x is 9 x squared. This chunk we have a negative x cubed, so that'd be a negative 1/4 x to the 4th, plus a 9 x squared. So we value. We put in 0, we get 0, minus, put in -3. So -3 to the 4th is 81 over 4. -3 squared is 9 times 9 over 2 would be 81 over 2. Put in a +3, so -81 over 4 plus 81 over 2 minus put in 0. So we get 81 over 4 plus 81 over 4, or 81 over 2. And it had to turn out to be positive because I wanted that absolute value. If we just integrated from -3 to 3, we would have ended up with a 0 on this one because you had equal amounts above and below the x-axis. Questions on that one? Okay, just a few more. Fundamental theorem of calculus to find the derivative of this. Should be dx because x is my variable within this. I flipped the x and the t this time. So what's the derivative of an integral? Yeah, we've learned we can work it out, but they should undo each other. But since this is going to a variable, all I have to do is replace the variable in here, which is the square root of t squared plus 25. And that was from Friday. G of x is the integral from 0 to x. So g of x is the integral from 0 to x of my sine qt. So tell me what g prime of x is. What's the derivative of this integral? Sine cubed x. You don't, when the integral goes away, the dt goes away. They're together. What if this had been a 2x? What would that change? Right. Our angle would now be, we'd be replacing it with the 2x, but then remember we had to do the chain rule, so times the derivative of 2x would be 2. So we could go from a constant up to any variable, and if it's not just the number by itself, you have to do chain rule. All right, last problem. Solve this initial value problem. So we started class with one of these today. The derivative is equal to tangent. Right, so we are trying to work backwards and figure out what this would be. So before a derivative, you had an antiderivative, right? Do we have a nice function? Can we do the antiderivative of tangent? No, so we're just going to have to leave this as an integral because we don't know of anything that has a derivative of just tangent. But I can't just make this an x, so I would have to make it a t for the moment. Okay, and we know if we go from a constant up to a variable, so what would my variable be here? X. When I did the derivative, it would become a tangent x. Okay, and this would have to be a dt because my variable is currently t. Where would I want to start this? Y of 1 equals 2. Okay, I don't want to try to figure out the tangent of what is equal to 2. That's going to be a headache. But if I start this at 1, we know from 1 to 1 that would be 0, so that integral would mean nothing. So how do we get it equal to 2? Add 2 on the end. So this is a strategy when it's something that we can't integrate. We're just working backwards and telling what the original problem could have been. All right, so we are done, and you guys have a ton of time right now to get this assignment done. It is due tomorrow, and we will be moving on.